you all. It's under practical 2, under practice test or something like that. You need to know a test. The test set up the substrates, the reagents, the pH indicators, the presence absence indicators, the results, pH of results, end products, enzymes, and how to evaluate the test. Okay? So let me just give you a couple of things that you should know to make your life easier. Number 1, if I ask for a pH indicator, there's only 2 choices. So it becomes 50-50 at this point. It's either phenol red or bromothiomo blue. And if you don't know, guess phenol red, because there are 3 tests that have phenol red in them. There's only one that has bromothiomo blue. Citrate has bromothiomo blue, everything else is phenol red if it's a pH indicator. Okay? The second thing you need to know is that if I ask you for a substrate, a lot of times if you know the name of the test, you know the substrate. What's the substrate in the nitrate reduction test? Nitrate. What's the substrate in the casein hydrolysis or the skim milk hydrolysis test? Casein. What is the substrate in the starch hydrolysis test? So that's the way it goes. The only ones that aren't for sure like that, of course, are the MRVP, and the substrates for MRVP are what? Glucose. Glucose. Okay? So those are my big hints for you all that make this practical fairly easy. Okay? I'll ask about everything that is on this list. So carbohydrate fermentation test, also known as the phenol red broth test, the starch hydrolysis, lipid hydrolysis, also known as tributylin hydrolysis, casein hydrolysis, also known as skim milk agar, gelatin hydrolysis, DNA hydrolysis, also known as DNase test, SIM, sulfur endomotility, methyl red, Rhodes Proskauer, citrate, triple sugar iron, urease, and the nitrate reduction test. The things that I thought we were gonna do, but we didn't, and I made a slide for it already and put it on Blackboard, was these, the catalase, the deaminase, and the decarboxylases. Dr. John got Myra to move them to after spring break, which I'm okay with, because it makes more sense there when we start doing diagnostics. So I will not ask about these tests, okay? All right, so now let's practice. So this is the SIM test, right? So what do initials SIM or the acronym SIM, what do they stand for? Sulfur endomotility. Very good. How do you inoculate an SIM medium? With a straight needle. It's a motility test. You inoculate it with a straight needle, go about 3/4 of the way down, then back up. Try not to move it, right? Because we're going to evaluate based on, does it grow only at the site of inoculation, or does it grow outward? Okay? So now let's talk about the reactions. What's the reaction in tube A? You'll have to listen to me, and you'll have to be very sure that you understand what I'm saying. So if I say something and you don't understand, you can raise your hand, you can say, will you clarify that for me? Okay? So here for tube A, I've got no red, no black, and I've got what appears to be growth only at the site of inoculation. So do you remember how you're gonna report results in SIM? You're gonna write SIM and then you're gonna put a plus or minus right by it. So S,
Negative.
I,
Negative.
M,
Negative.
very good. No, M, it's not modal, it's only at the site of inoculation. Okay? So be sure you listen to me. Okay, so this would happen here, Sarah. I know you can see it. It looks like it goes out that way, right? But what happened here is somebody went in and then they moved, but it's not fuzzy at all. Okay? Good? Okay, here I've got red here and fuzzy there, so S, negative, there's no black, it's negative. I, positive, it's red. And M, no, it's fuzzy, it's fuzzy.
Perfect. We got more?
Yeah, I got mine. They were hungry.
I know.
So the last one here, I've got black there, I've got red there. Go, S, okay, you assume it's modal, right?
Positive, positive, positive.
Positive, 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 that's correct. So what have I asked? What is the substrate in the endo test? You'd say what? What's being broken down? Gobble, gobble.
Tryptophan.
Tryptophan, very good. tryptophan. What if I asked, what is the presence absence indicator for hydrogen sulfide? You'd say ferrous ammonium sulfate or iron. I would rather you just say iron, it's easier to remember. Okay?
Wait, how do you spell?
Iron, I-R-O-N.
Oh, I thought you were saying wrong.
I'm having fun with iron.
And that's the presence absence indicator.
Presence absence. There's only two presence absence indicators. There's one for hydrogen sulfide, ferrous ammonium sulfate, iron, and then there's methyl green for the DNAs. Okay? Good? This is the way it's gonna work. Yep.
So for instance, for the middle, test tube,
Yeah.
would you say on the practical that it is fuzzy or it is turbid?
I said it was fuzzy,
Okay,
and you just missed it.
okay.
I'll try to slow down. I'll try to drink less coffee on Thursday. Okay? But you can remind me, Pro V, slow down, right? Because I'm not here to be an obstacle. I'm here to help you learn. Okay? All right. Everybody cool with this? All right. Let's go. So this is the citrate test, right? So first of all, if you appreciate it's green and blue, immediately you should know the pH indicator is what? Bromothymol blue. It's the only one. Everything else, if there's a pH indicator, it's phenol red. Okay, so let's answer the questions. Why is citrate called a defined medium?
It's chemically defined.
It's chemically defined. So what does that mean, Bruce?
You know what's in
You
it.
know what's in it. That's all you need to put down. You know what's in it. Right? You can say there's a recipe, you know what's in it, it can be remade, whatever. All it tells the same thing, okay? What indicator is in the medium? What pH indicator is in the medium? Bromothymol blue. A blue color indicates what pH. Your choices are acidic, basic, or neutral.
Basic.
Basic. Good. Because when citrate gets broken down, ammonia is released, and ammonia is more basic. It changes the actual pH of the media to become more basic. Therefore, it turns blue. Acidic conditions for bromothymol blue are yellow, neutral conditions are green, and alkaline conditions are blue. Okay?
So
Did you
the
see?
one on the right is neutral?
That's correct.
Okay. Will you ever show us an image of a yellow one next to the blue
No,
one?
because it doesn't exist.
Why?
So, well, because if you break down citrate, the products that you break down citrate to will never be acidic. They'll always either be alkaline or neutral.
Okay.
Okay? That's a great question, though. Great question. But no, unless I was just mean, I would never show you yellow.
Okay.
Okay?
We might find out.
Oh my God.
All right.
I love it.
So a positive citrate is what color? Blue. A positive means that the microbe can use something as its sole source of something.
Citrate.
Citrate as its sole source of?
CO2.
Carbon. Carbon.
Oh, just carbon.
Just carbon. Remember, carbon is a really important atom, but it just carries the important things. And the important things are what? Hydrogen, right? So when this organism breaks down, takes it metabolically, it can produce ATP later with the hydrogen. Yep, just that.
Would you ask about it being sole source of nitrogen as well, or?
No, well, where did you get that from?
Uh,
I mean, there's a real good reason why you're saying that, I get it, but it's not really breaking down nitrogen. What it's doing is it's releasing the amine group, which is then picking up a hydrogen, becoming ammonia. So it's not really, no, I wouldn't ask about sole source of nitrogen. Okay? All right, this is the MRVP test. Let's talk about MR first, right? Describe a result of a positive, oh, wait a minute, I passed one. What is the reagent added to the medium after incubation to evaluate the MR test? Methyl red. It's called the MR test because it's the methyl red test. And if it's positive, it turns red. What does it indicate? What end products does it
Acid
indicate?
end products.
Acid end products. You don't know which one. It can be lactic acid, it can be pyruvic acid, it can be succinic acid, it can be a whole bunch. We don't know which one, we just know it's acidic. Okay? The test is a part of a something battery of tests that we use to identify something enteric bacteria. So what's the battery called? MVIC, very good. And MVIC stands for indomithyl red volts proskyr citrate. And what is the gram specificity of enterics? Gram negative. That's correct. Okay. What's the primary substrate in the MR or the VP test? Glucose. Everybody has found the matrix, right? Everything that you need is on that matrix. Everything that you need is in your lab reports, right? So you've been creating your own study aids the whole time, but I've made it even more simple than that. There's a matrix on Blackboard for you if you want to find it. Okay.
What was the battery called again?
IMVIC, IMV, little tiny sub IC. You can come on in, Ohan.
I'm about to go to lunch, Joey, thank you.
Okay. Anybody got questions? You want a piece of cake, Ohan?
I'll get it after.
Okay, fine. All right, here we go. This is the VP portion. Describe the results of the VP test. So for instance, if the organism tested VP positive, it would be MR positive or MR negative. Negative, right? Because the VP end products it's being tested for are neutral, but the MR tests for acid end products, right? Okay? So therefore, if it's VP positive, it has to be MR negative. Okay? Name the reagents that are added to the VP test.
Potassium.
Yes?
Potassium hydroxide.
Potassium hydroxide and naphthol, or alpha naphthol. Okay? Now, when you add it, it takes 15 minutes. Provi is very impatient. So therefore, we add something. We add creatine, and the function of creatine is what? Catalyst. It speeds up the reaction. So a positive VP would be what color?
If you watch the Love Boat now.
A positive VP would be what color? Burgundy, red burgundy. Either one of those is fine. Okay?
So inappropriate.
Anybody got questions?
Like, this would not be allowed on TV.
This will be close.
Yep.
Okay. So, what if I did this? Which I will, because this is what I have. Give me the result for a positive MR and a positive VP. Huh? It's an error. Give me the results for a negative MR but a positive VP. Neutral. Give me the result for a positive MR, negative VP. Acid. And if it's not acid and it's not neutral, it is. Okay. Be sure you understand how that works. And don't memorize them because I'll mix them all up and then you're gonna have to figure out what's what. Okay? Okay. Indole. Describe a positive indole test. Has a red lake at the meniscus. Very good. Indole is the end product of the digestion or the breakdown of which amino acid? Gobble, gobble. Tryptophan. And so the positive test is seen as a positive for what enzyme production? Tryptophanase. It's a complex, tryptophanase. What reagent is added to the tube after incubation to evaluate the indole test? Which one? Kovacs reagent, that's right. Kovacs reagent. Okay? This is a nitrate test. Just listen to me because I'm gonna make it more fun than this. So in the nitrate test, after you inoculate the organism, you come back in 24 hours, and in step 1, you add 2 reagents. Which reagents do you add for the step 1 of the nitrate test? sulfonyllic acid, don't say the acid, sulfonyllic acid, and naphthylamine, don't say naphthol, naphthylamine. If you get a red color, what does that indicate?
You just pulled that.
Positive for nitrate being reduced to nitrite, nitrite present, or you can write it like this, which is absolutely fair. That's exactly what that is, okay? So there's lots of ways to say it. If you get no color developed, then one of two things have happened. Either nitrate is still there in its pure form, or the nitrate has been reduced to a gas. We figure that out by adding something. What do we add? Zinc. And what's the function of zinc? It's a what?
Test for the presence of nitrate.
What? I didn't hear what he said. I have my hearing
It
aids.
breaks down.
It's a reducing agent. So once you add zinc and you get a red color appear, immediately, what does that mean?
No breakdown.
No breakdown, negative, right? Or no reduction. If you get no color after the addition of zinc, then what?
It's like a.
Nitrate to a gas. Gas present, or we can write it like this. And it doesn't make a difference which gas, because we don't quantify or qualify which gas. It's just a gas. Okay? I mean, I can make that all kinds of different ways. Okay? Good? Yes?
So like, I was talking to the lab mates, but like, if we put in the first acid, I forget what it's called,
Sulfonyllic acid?
sulfonic acid, and like, there's like a slight color change, like it turns more orange, that doesn't signify or indicate anything.
And you've not done anything else? I don't see how that would happen.
We had a color change in one point.
Yeah, from.
It wasn't
from
pink,
the
it was a
first
different
step,
color.
it was like a kind of a peachish color, went from yellow to like a peachish.
Yeah.
With just sulfonyllic acid?
Yeah.
I don't know what happened. I can't explain that.
We're special.
And probably. And you didn't add naphthylamine and thought it was sulfonyllic acid, because naphthylamine is a little pinkish in color as it is. So if you added naphthylamine without the sulfonyllic acid, it would have turned a little pink.
We just did the A and the B.
Yeah, I went in the right order.
Okay, fine.
Dog protein.
Yeah, no. All right, anybody else got questions about nitrate? Yep.
If it turned sort of fuchsia, would that have been positive for nitrite?
It doesn't, this one doesn't turn fuchsia at all.
So that would have been an error.
Well, I don't, maybe, it might not be an error, Fatima. What might happen is maybe my color scheming is a little bit different than yours. But I will use, for this one, I'll use red. Because there's no phenol red in here, so it's not gonna be fuchsia. Okay, I won't use the color fuchsia for. Is this what you're saying fuchsia is?
That's just a little bit of
Okay, yeah, I won't use I won't use the term fuchsia for the nitrate test, it'll be red. Okay? Okay, now this is fuchsia, for sure, right? So this is the urease test, also known as the urea hydrolysis test. So a positive urease or a positive urea hydrolysis is what color? Fuchsia, hot pink if you wanna call it that. Why? It's basic, because it's become more basic, right? The indicator in the medium is what? What's the pH indicator? Phenol red. And the pH of this tube is acidic, basic, or neutral? Basic. The end products of urea or the breakdown of urea are carbon dioxide and ammonia. We don't care about carbon dioxide. It gets liberated, goes up into the atmosphere. But ammonia changes the pH. Okay? Any questions?
He said the pH indicator, methyl red is basic.
Not methyl red.
Phenol red.
Phenol red. Phenol red is not. Phenol red in this capacity here, where it's fuchsia, it's basic. Here, it's neutral,
Okay.
okay? And when it's yellow, it's acidic.
What color is the one with the cola you're saying?
This one right here,
Yeah. No,
That's
over-
fuchsia.
no, what color is it?
what's that?
That's not
The
yellow.
E. coli. What color is E. coli?
E. coli would be yellow. Oh, in this test, it would be light pink.
So that's
That's why I say, you know, if it's fuchsia, it's positive, any other color is negative, okay?
So fuchsia is positive and it's basic. And.
Those are two different things. It's positive because it's fuchsia, but it's turned fuchsia because basic end products have been added to it. That's why it's become more basic.
Yeah.
It's the biochemistry behind the test.
And then yellow is neutral.
Yellow would be acidic. Be-
Oh, okay.
because
Yeah.
phenol red phenol red is yellow, and when it's yellow, it's acidic. When it's orange or red, it's neutral. When it's fuchsia or hot pink, it's basic. That's the range of the pH indicator. Okay? Questions? We're gonna see that in action in just a minute, Kim.
Yeah.
Yep. Okay. Here we go. So this is TSI, right? So let's answer the questions. What does TSI stand for? Triple sugar iron, right? Name the three sugars in the medium. Glucose, lactose, sucrose. I probably won't ask it like that. I'm gonna ask it this way. Name a sugar that's there in 1%, and you'll say, no, not glucose. Lactose or sucrose. I might say, name the sugar that's there in 0.1%. You'd say glucose. Okay? So glucose is there in a lesser concentration. Absolutely. It's the mechanism,
You said the sucrose and the fructose is 1%?
not fructose. So lactose and sucrose are there at 1%, and glucose is there at 0.1%. And it's important because if glucose is being utilized, only the slant turns yellow. But if lactose or sucrose are being utilized, the whole thing turns yellow because they're there at a higher concentration. Okay? All right, so how does one inoculate any slant, but in this case TSI? SSSB. SSSB is all I need. Now let's interpret this. So when we interpret, I will direct you as to what colors are there, and then you'll tell me the answer. So you'll draw 2 forward slashes, yes? I've got yellow here and orange here, so go. What's the reaction in the slant? Acidic. A, then, and then, no gas. No gas.
So we write no gas.
No gas, you write no gas, that's right. Okay, let's go on. So here I have fuchsia here and fuchsia there. So go. Go. K, K, no gas. Okay. So I'm not gonna ask about coliform, non-coliform because I didn't cover it at all. It's important for me, but not necessarily for you. Okay? Then here, if we think about it, right, what is added to the medium that allows for black precipitate to form? Iron. Right? You can say ferrous ammonium sulfate, but it's easier just to say iron. Okay? I'm not gonna ask about the enteric that's a non-coliform, but let's go ahead and interpret the result. So I've got fuchsia here and black there. Go. K, A, no, hydrogen sulfide. So it's Ka hydrogen sulfide. Because it's black.
H2S,
H2S, hydrogen sulfide. Okay? Good? So here I have fuchsia here, I have yellow there, and I have cracks and fissures.
AA gas.
Ka gas, that's exactly right.
Good job.
Who said that?
Rebecca.
Okay, yes, that's correct. All right, so here you can see that there's so much gas that it just cracks the medium and pushes it up into the tube itself. It's pretty cool when that happens, right? So let's do a couple of these. Let's do this one, go.
You said
A,
it?
gas. How about this one? I got fuchsia here, black there, go.
Outline.
K, A, H2S, very good. So how about here? I got yellow here, and I got cracks and fissures, go. AA gas. Okay? Good? Let's do one more. I got fuchsia there, KK, no gas. Yes, Josiah?
So the only like time we have to name a specific gas is when it's black?
Correct. Because the other one, you don't know which one exactly. It can be methane, it can be CO2, there's a bunch of gases it can be. We don't know which one.
Unless it's like an extreme case, like A, you're gonna say it has cracks and fissures.
It has what cracks and, I will say that.
Okay.
So even if you're looking at it and you're like, it looks like I might have a crack, but I said no cracks or fissures, then go with what I say, okay?
There are no cracks.
There are no cracks or fissures, okay, good? Okay, so this is the DNase hydrolysis test, right? This test is used to detect the enzyme DNase. Why is DNase called a ribonuclease? Because it detects the DNA molecule or it attacks ribose. Either one of those would be fine, or DNA, deoxyribose. What's the indicator in the mean? This is the presence absence indicator. What's the presence absence indicator? Methyl green, that's correct. And describe which one is positive. Is Staph aureus positive or Serratia marcescens positive? Serratia marcescens. Just like that. Okay, so what's the substrate in the MR? What was it? Glucose, very good. What's the substrate in nitrate reduction? Mhm. What's the substrate in VP? Glucose. Glucose. This is a gelatin hydrolysis test. What's the substrate in the gelatin hydrolysis test? Gelatin. Mhm. What's the purpose of placing the tube at 4 degrees Celsius after 24 hours?
So it doesn't melt.
It allows the gelatin to repolymerase or solidify if it's negative. If it remains liquid, then it's positive. So therefore, what's the result here? Negative, it's not liquid. Okay? Oops. Okay, covered those already. So we covered that. Okay, here is the carbohydrate fermentation test, also known as the phenol red broth test. So this is, the C is the control, right? That means it's not inoculated. So which test above indicates fermentation? A, that's correct. It's acid with gas, which represents acid only. B, identify which tube above shows alkaline byproducts only. D, that's correct. Name the pH indicator. Phenol red. You sure you know some lab rules? I don't know what I'll ask. I have to ask at least 5 questions in the lab, safety, lab management.
Wait, where's the rounding point?
Well, evidently it's right out there now, all right? I would have taken you over there, I asked Myra, but the campus manager redirected, so whatever the campus manager says, that's.
I said, that way, yes,
Yeah,
ma'am.
okay, yes ma'am, thank you. Thank you for playing,
What
I'm
would
there.
we call that on the lab practical if we pass that? What would
I'm
we-
not gonna ask you that, I promise I won't ask you that.
That's like, what's on our.
Typically, that's where we would go. I know, but
Cause I almost started.
I'm
but I was like,
never going to, like Myra said, the campus manager, I'm like, okay, if the campus manager said to go that way, we're going that way. All right, so here's the starch hydrolysis test. What's the substrate? Starch. Which reagent is added? Iodine, very good. A or B, which one's positive?
B.
B. Mhm. B. Okay.
No, we can't.
Yes, you can. There have been thousands of students that have come before you with less aptitude, and they've done just fine. Why would I expect you would not do just as well?
Can you go a little bit, I think I made.
Anybody have any questions?
Can you go
Which way?
I don't.
One back?
Yeah, back, more. Let me get, yeah, that
You
one.
know, this is on Blackboard for you, son.
Okay.
So if you want it,
Mhm.
you can go to Blackboard,
Mhm.
and underneath